we have free electron concentration N naught equal to in this formula we have N naught, Nc, Ef, Ec and the temperature T. Providing any 4 parameters, the fifth parameter can be asked. Now we will rearrange this formula to find the position of Fermi energy in terms of other 4 parameters. This is a required formula to find the exact position of Fermi energy with respect to conduction band energy level. This formula can be rearranged as you can see that the same formula can be rearranged in different manners. Obviously, there is no need to learn different forms of the same formula as you can rearrange the formula within seconds in the exams also. But we have a special case when free electron concentration N naught is equal to hole concentration P naught. And by now, you should have already determined that this particular case is of intrinsic semiconductor. We have free electron concentration N naught equal to. Similarly, we have hole concentration P naught equal to. Now we simply equate the hole concentration with free electron concentration. This is the final expression. An important question is, what is EC plus EV divided by 2? If you recall that when we draw energy band diagram, then we first draw conduction band energy level EC, then we draw Fermi energy level EF, and below it we have valence band energy level EV. EC plus EV divided by 2 is nothing but the exact midpoint between EC and EV. It will be better to write Fermi energy level to be EFI so that it will be easier to remember that this formula is valid only for intrinsic semiconductor. You may come to see other forms of this particular formula. As you know, the effective density of states in conduction band Nc is equal to. Similarly, effective density of states in valence band is equal to. If you put these values of Nc and Nv in the formula of intrinsic Fermi energy level, then we will get EFI equal to E mid value plus 3/2 multiplied by 1/2 multiplied by kT into natural logarithm of effective mass of hole divided by effective mass of free electron, which will result to E mid value plus 3/4 into kT into natural logarithm of effective mass of hole divided by effective mass of free electron. E mid value is EC plus EV divided by 2. Now we will analyze the Fermi energy level for extrinsic semiconductors. First, we will take N-type semiconductor with doping concentration Nd, and generally doping concentration is significantly greater than intrinsic carrier concentration. In such cases, free electron concentration at thermal equilibrium is approximately equal to doping concentration. Now, as we know, free electron concentration is equal to. Replacing N0 by Nd, we will have so the Fermi energy level will be equal to Ec minus kT multiplied by natural logarithm of Nc divided by Nd. Similar analysis can be done for p-type semiconductor. Here also we will assume that hole concentration is approximately equal to doping concentration and doping concentration is significantly greater than intrinsic carrier concentration. Whole concentration P naught is equal to. Now replacing P naught by Na, we will have so we have the formula for calculating Fermi energy level for p-type and n-type extrinsic semiconductors. These formulas are very important for exams. The Fermi energy level for intrinsic semiconductors as well as for extrinsic semiconductors both are very important. Many questions are framed from it. Learn these formulas and also remember from where and how it came.